Okay, today moving on with our vector stuff. So here, collinear or collinearity. Whoops, collinearity. Um, so basically, in a straight line, these things all lie in a straight line. So here we go. 3 points are collinear if they lie on a single line. Here's our 3 points A, B, and C, and here's our beautiful straight line. So if they lie on that straight line, they are collinear. And so in terms of vectors, how can we figure out? So if we've got these vectors AC, A to B, then if it's collinear, given that there's a common starting point of A, then those vectors would be parallel, and then they would all be in a straight line. And that's what it says here. 3 distinct points A, B, and C are collinear, I should say, if and only if. Sometimes people get a little bit confused by if and only if. I'll explain that in a minute. So if there exists a non-zero real number m such that AC is m times AB. So there to there is some number times there to there. And of course that's a scalar, so that just makes it longer or shorter. But the key thing is the AC and the AB, because we've got a common starting point. If they are then equal, they're parallel. All right, the if and only if part comes is that if AC is equal to MAB, but the only if part is that that's the only time that these three would be collinear, is if this condition is met. All right, so that's a little bit different sometimes than the way than just saying if something. So like null factor law, AB is equal to 0. Well, that's equal to 0 if A is 0, but that's not the only time, because it's also equal to 0 if B is 0. All right, so there's a little bit extra here with the only if, because that's the only time that those three things would be in a straight line, is if this here is satisfied. And there, of course, that is if and only if AB and AC are parallel. And the key thing, of course, is they have the same start point of A. Okay, so let's have a look at an example where we might use that kind of thing. And so in your textbook, example 26, for distinct points A and B, let A equal OA and B equal OB. Express OC in terms of A and B where C is. And so now we have some conditions on point C. So let's have a look at part A, for example. So if I've got point A here and I've got point B here, and it says that C is the midpoint of AB. So here's C. So because C is the midpoint of AB, we know these 3 points are collinear. All right, and because it's in the midpoint, there's there. So let's say here's our origin O, so here's our OA, and here's our OB, which we're calling B from there. And so we want to know OC, so we want to know this here. So let's have a look and let's think of what we've got. So O to C, how else we could get to O to C? We could go from O to A and then from A to C. All right, so OC, could be O to A plus A to C. Now, A to C, of course, because we were told that that's the midpoint. C is the midpoint of AB. That's half of the way from A to B. Now, when we look at our thing A to B. Let me just change my colour here. All right, so A to B is going there and then to there. Now, there and then to there, well, this is A to O. And then O to B. All right. So now, in terms of those things, O to A is A. A to O, well, it's the opposite direction to A, so negative A, plus O to B, which is B. All right. So now when we expand that bracket, we've got A minus a half A plus a half B. So that's a half A plus a half B. All right, which again, you could take that half out as a common factor now and say that that's a half of A plus B. All right. So we're using that collinearity bit, and where it comes into is here, this part there, AC half AB. So going from there to there is the collinearity. That is the case if and only if, all right, they're parallel, are they collinear? The reverse applies as well. If they're collinear, then those vectors are parallel. Okay, now what's the point of trisection? Try into 3 of AB nearer to A. All right, let's go that point of trisection nearer to A. So nearer to A is there. Trisection into 3. So if it's into 3 bits, 1 plus 2 is 3. Yeah. It's our A. This is our O again. Here's our B. And we want to find OC. So the first bit of discussion, this here is the same. All right, OC is still OA plus AC. The difference in this time is the relationship between AC and AB. All right, and so trisection into 3 parts closest to there. So this bit would be twice the length of that. So that distance there is a third of the way to B. All right, then the rest of the same. Oops. OA first of all. Let's go OA. I'll change that later. Plus 1/3 of AB, which we did up here. All right, AO to OB. All right, which is then A plus 1/3 opposite direction of A, and A minus a third of A plus a third of B, so 2/3 of A plus 1/3 of B would be what we would get. All right, so there's part B. Again, we've used the fact that we've been told that they're collinear. So if we've been told they're collinear, we know these vectors are parallel. All right, then part C says point C such that AC is negative 2 lots of AB. All right, so part C, that AC was negative 2 lots of AB. All right, so A to C. I'll look at A to C. I've got to go A to O to C. So I'll go AO. And then I'll go OC. Equals negative 2 lots of A to B. Then A to B. I'll go A to O, O to B. Remember, we're working through, because these are position vectors, we're working through the origin. That's the common thing that pulls it all together. So A to O to O to B. All right, let's then put in what we know. A to O is the negative of A. Negative 2, negative of A plus B. Excuse me. And so OC will be equal to 2A minus 2B. And then I'm bringing this across here as well, which would be plus another A. So it'd be 3A minus 2B. All right. So there we go. There's an example. Collinearity. So things are in a straight line. And they are in a straight line. If and only if the vector from A to B and the vector from A to C are equal. And conversely, not equal, parallel, could be different lengths, are parallel. And also conversely, if you've got two vectors with the same start point that are parallel, then the 3 points are in a straight line. All right, if there's anything there you need help with, make sure you seek some assistance, and as always, have fun.